Assalamualaikum, my name is Nurinara binti Osman. My metric number B0820100348 and my partner is Sharvin. So in this video, we want to show you guys on how to do simulation on lab 3, which is coefficient of static friction. The first step is click the sum of force, values and masses. Choose the box with mass 15 kilo. And now drag the person toward the box and apply 15 Newton. And then set the friction to halfway. As you can see, there's the box not in motion and not moving. So the friction force and applied force get the same results, which is 15 Newton. And the sum of force is 0 Newton. So the next step is when box in motion, we increase the applied force to 150 Newton. So as you can see, the box is moving, and the result of the friction force we get is 94 Newton. The applied force is 150 Newton, and lastly, sum of force is 56 Newton. So the last part, when 100 kilobots in motion, we put another 15 kilobots and set the force to 500 Newton. You can see the box is moving and the friction force is 188 Newton. The applied force is 500 Newton. So the question asks the magnitude of applied force necessary to move the box at constant speed. So you can see that the friction force is 188 Newton and the sum of force is 188 Newton. Also to the left. So we increase the applied force to 500 Newton. While the box is still moving, we remove the applied force to 0 Newton. Immediately friction to none. So we can see the box is still moving. Then increase the friction to lots. As you can see, the box is stopped moving.
Good evening, sir. My name is Sharvin Rao and my metric number is B0820100169. Good evening, sir. So today I'm going to show you the simulation for lab 3, which is the coefficient of static friction. So given in the table 1, it's a wood box on a wood surface at a 0 degree angle. So the wood box has a coefficient of friction of 0.25 given in the lab sheet. So in the simulation page, I'll set the M2 to 10 kg. Okay, I'll set maybe to 8. I'll set it to 8. Then the coefficient of static friction, I'll set it to 0.25. And the angle, I'll set it to 0 as given in the table 1. And then I'll press run. So I've got to find out the mass of M1 until M2 moves towards M1, like it's said in the procedure. So for 4 kg of M1, it's still pulling the M2, so I need to decrease it some more. .2 kg is still pulling M2, so I'll have to decrease it some more. And 2 kg looks great. The M2 is not moving towards the M1, so I'll record the M1 of this simulation. So as you can see from the table, for a weight of M2 at 8 kg, the M1 is 2.0 kg. At this weight, the M2 is not moving towards M1, so I recorded this So the M1 I recorded in kg is 2.0 as it was in the simulation result, and I converted to Newton by applying the formula F equals to mg, and I got 19.6 Newton. So for the rest of the table it's the same. For the second table I set the coefficient of friction to 0.25 and the angle this time I'll be setting it to 30, and I will stop the simulation when M2 moves towards M1, and this is the weight I recorded for M1.